We're going to be looking at lesson 13, and this is the first video for lesson 13, sketching gradient functions. So it's a really handy skill to be able to sketch gradient functions because we can look at key features and how they relate to each other through the gradient function, but also the gradient of the gradient function, which is the rate of change of the gradient. Okay, so we've got two functions here. The one on the left here is going to be the worked example, and the one on the right-hand side, I want you to have a go at afterwards. So we are asked to just sketch this, the gradient function underneath. So first thing, that shouldn't say y, this is our f dash of x. So this is our gradient function. Same over here, you need to find the gradient function here. So let's go through some key things. Key features we're looking for when the gradients are 0. These are our stationary points. Okay, now we know stationary points come in 3 flavors. We've got this one, and then either, and I always draw this wrong just to start off, hopefully I get that right. No, I didn't, that's a VPI. Let's try again. We want to draw it like this, good. That or this. Okay, so we've got a max, a min, and HPI, so horizontal point of inflection, and one is decreasing and one is increasing. Okay, so these are our stationary points. Okay, and we want to look out for these. So let's have a look at this first function. Now, I like to go through like this. This is all negatives here. Okay, negative, 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 and then it goes positive here, right? So as we go along, we see the gradient, it's very negative here, drops off, goes negative again, then goes positive. Now, there's got to be some interesting points in between it, i.e. that point there, we can see that the gradient is 0. Okay, so 0 gradient. So at one point there, it stops, and we know that this is a horizontal point of inflection. We can see there, the decreasing variety. We also have this point here, which is special. It's also another 0 gradient. And this one here is going to be a min, a local min. Now, what's important about this is I basically draw, and you can just draw a line down if you so wish, line down if you so wish, and then we know that the gradient of these points is 0. So I can draw a dot here and a dot here to say, yep, those are 0 at those points, okay? Now, what else do we have? What are some other key features? The next key feature I want you to look for are, so this is another key feature, VPI. Remember, it stands for a vertical point of inflection. Okay, now this is where the gradient is the steepest in a region. Okay, and let's draw some pictures of that. And I drew one before. So you've got two kinds of these. You've got one where it does this. There's your VPI, or you've got one that goes like this. There's your other VPI. So these are both VPIs, and this one's a decreasing, and this one is an increasing VPI. So let's see if we can find those. So there must be a VPI here. So probably about there. That's the steepest gradient. Now this is the steepest negative gradient. So I'm going to draw this down. And this is maybe a point like this. This is where it's negative and steepest. So therefore it's going to turn into a turning point. Okay, now everything else we can just make a sketch of. I don't think we have any other key features that we really need to care about here. So we can now consider this. Over here, we can see that the function is a negative, in the negative gradient, therefore it's going to be here. Okay, and I'm just going to draw a picture of this. If I'm looking at f dash of x, the negative gradients, and I'll make that red, negative gradients, you should be in that region there. And for a positive gradient, you should be in this region up here. And if you have a 0 gradient, you've got to be on that line there. Now, I hope that makes sense. Positive, this is a negative, and this is where the 0 gradient is there. Okay, so that's why we've got this bit here as being a minimum. Okay, so we know it starts here at yellow, it's negative, and it gets more and more negative. So let's draw it like this. Okay, it reaches this point here, it stays negative here, so it comes down, and then we can see it must balance out again, and then come up. And at this point here, and I'll draw that a little bit better, it goes from negative to a positive gradient, and it keeps getting more and more steep. So something like that. So there we go, we've just drawn the gradient function of f of x below. Okay, now we're going to continue this and find what the next gradient, the rate of change of gradient. So we're going to do this process again. Okay, so let's have a look. We've got, this is positive gradient here, then it gets to 0 here, it goes negative, and then it goes positive, and it stays positive, and it's getting more and more positive. So gradient here is 0, so therefore we know that this point here is going to go to 0. And we know the gradient here is 0, so we can copy that down as well, like that. There's no other 0 gradients that we found, no other stationary points. We can see that there's a horizontal point of inflection, maybe there. That's the steepest negative gradient again. So that's going to turn into a turning point down here. So maybe it's like this, I'm not quite sure. Now we can see that it's positive here and positive here, so we should see that in the positive region, and we've got a negative region here, so it should be below the x-axis. Okay, so if we put all this information together, we make a function like this. Okay, and there we have it, we've got our function there. Okay, so we've just found f double dash of x, so this is the rate of change of the gradient. Okay, now what I want you to do is have a shot at g of x, try to do that same process, so pause the video, have a go at it, and then press play when you're feeling like you've got it. Okay, so let's go through the answers here. Let's go through our key points. Got this one, these are both 0, and I've got here, this is a max, and this one is an HPI. Let's scroll down, and I should have a stationary, the gradient is 0 at that point there, and a gradient is 0 at that point there. Let's see what's happening here. I'm going to highlight it this time. So we've got a positive gradient here. It switches to negative all through here, and it stays negative the whole way. Okay. Now that means there must be a VPI here. We can see it must be the steepest gradient here. So this is steepest negative, so it turns into a turning point. Okay, so maybe it might go here, for instance. Now we can also see that it's staying negative, so it must bounce there. Okay, so let's draw a graph of this. Goes like this, comes down, turning points here, comes up, bounces, and then goes down. Okay, so that should be the first function that you have. We do the same thing again. Highlight when it's positive. It's only positive here, and the rest is negative, okay, or negative gradient. So let's go through and find our key points. Let's go, what color haven't I used? Like this is green. Looks like we've got a min there. We've got another stationary point here, a local max, it's the gradient, and that means we must have some kind of VPI here. Okay, now this time it's a maximum, okay, instead of a minimum, because it's the maximum gradient in that region. Okay, so let's have a look and see what this makes. So min, max, they copy down here, and we've got our max positive here, and then we can just sketch the rest. So it looks like it's going to be something like this, like a quadratic, like that. Oh, let's try that again. Okay, there we go. Right, so we've got our functions there. Okay, now what's important about this is we can start tracking what each of these key points do. So let's have a look. If I've got a minimum here, what happens to that minimum? Well, the gradient of minimum, the stationary point, goes to 0, and then we can see that later on it's positive. The rate of change is positive. Okay, what happens to a horizontal point of inflection? We go down, it becomes a gradient of 0, and it also has a second gradient of 0 as well, so HPIs. Let's have a look at the VPIs. So here's our VPI there. Scroll down, so that's got the steepest negative gradient in that case, and then that goes to a 0. And we can use these facts to help us recognize these key points using calculus instead of graphing. So hopefully this video was useful. It's a little bit of a strange process, but once you get the hang of it, they're quite satisfying. So please, there are some more examples like this at the end of lesson 13 as well, just for you to practice. Okay, hope this video is useful. In the next video, we're just going to make a table that summarizes all these key points, and then we're going to get into some questions. Thank you very much.